Okay, good morning, Team Impact. We are moving on to mean absolute deviation, or you'll hear it referred to as MAD, as the MAD. So we just got done doing a great warm up. If you missed it in class, apologize. But we took about 20, 25 minutes to warm up the first three. We're looking at a quiz on Thursday over lessons 1 through 5. This is 4, so we're going to go over Wednesdays, which is dot plots, and then that's all going to be on the test. Anyway, let's get started. I hope you have your calculator handy. You're going to need it today. So the MAD, or the mean absolute deviation, is what I kind of refer to as the mean of the mean. And you'll see what I mean in just a minute, right? One way to describe variability, or how spread out a set data is by using the mean absolute deviation. Instead of writing all that, I'm just going to write MAD. Okay? The MAD is the average distance that the data point in a set of data are from the mean. All right. A MAD close to 0 means that the data values are close to the mean. Okay. And that just talks about the cluster of data, how tight it is. All right. Steps to calculate the MAD. All right. So there's certain things that we need to do. All right. And all of these things you have done before. First, you're going to find the mean. All right. You're going to find the mean. All right, of the data set. And then you're going to find the distance, right, from each data point and the mean. And then you're going to find the average, all right, of those distances. And I'll pause there for a second and chat with you. So first thing we're going to do is we're going to add up the data values and divide by the total number in a set to get the mean. Then we're going to take that mean and we're going to subtract it from the distance, all right, from the data values in the set. All right, and then we're going to average all of those up and get the mean of those. And that's why I keep telling you it's really the mean of the mean. All right, so let's get started here with number 1. And here we go. So first thing I'm going to do is grab my calculator. All right, and here it is. So the first thing I'm going to do is find the mean of that data set, right? So 20 plus 19. Make sure that you're putting in the correct values and double check your calculator, right? 14 plus 17 plus 18 equals. All right. So my value is 126, and I'm going to divide that by 1, 2, 3, 4, 5, 6, 7. And when I divide that by 7, I get the wrong answer. I hit the wrong button. Let me try that again. 126 divided by 7 is 18. So 18 is our mean. Okay, I got a funky decimal, so I knew I made a mistake. Okay, so what we're going to do here on our next phase, all right, is we're going to find the distance from each data point from the mean. So we're going to subtract all of these numbers from 18. Now, whether the number comes out in a positive or a negative, we're always going to write its absolute value. Remember, absolute value is a number's distance from 0. So 20 minus 18 is 2. And remember, I'll do this right here. 19 minus 18 is 1. 18 minus 15 is 3. And you'll notice I flipped that over because that number was smaller than my mean. Okay? 23 minus 18 is 5. Hold on.
Please call the front office.
18 minus 14 is 4. 18 minus 7 is 1. 18 minus 18 is 0. Okay? So all as I did was take my mean and I subtracted each of these values in the data set, which are the same here, and got those. Now, what I'm going to do is add all of these up. 2, 3, 6, 11. 11 and 4 is 15, 16, and 0 is still 16. So my sum is 16. All right. So what we're going to do now is we're going to find the mean of the mean. So we're going to take 16, right, and I'm going to divide it by the total number of data values in the set, which again is 7. all right? And 16 divided by 7, and let me grab my calculator here. 16 divided by 7 is that big crazy number. Now, what I'm going to do is I'm going to round that to the tens place, okay? So let me go back. 16 divided by 7 is that. So I look to the right, that's 5 or greater. That shoves that 2 to a 3. So that's going to be approximately 2 3/10. That is what we call the mean absolute deviation, right? So this was B. This is what they want there, and we're going to put an approximation, all right? So what does that tell us? Explain what the mean absolute deviation tells us in this situation. Well, that means the average number, the average distance, excuse me, these numbers are from this is 2.3. That's a small number. It's close to 0. Remember they talked about that back here? So when it's close to 0, we have a nice tight cluster of data. And the spread of the data, really, if you look at that, is 14 to 23. So when you look at that, what is that? That's 9. So there's only a range of 9 numbers there. Okay, let's continue on. Let's flip the page. And let's go again. Okay, if you like that calculator, man, this is your unit. Next one up. Here's our number in the data set. So let's go ahead and find the mean. Let's add those up. 8 and 8 is 16. 16 and 26. And 10 is 36. 36 divided by 1, 2, 3, 4, 5, 6. 36 divided by 6 is 6. Okay, so that's going to be our mean of the data set, right? So now I'm going to subtract that from all of my values. 6 minus 3 is 3. 6 minus 5 is 1. 8 minus 6 is 2. And again, you'll notice I'm flipping these numbers over. 10 minus 6 is 4. 6 minus 4 is 2. And 6 minus 6 is 0. We still have to count that when we divide, even though it's 0. So let's add these up. Again, I haven't even used my calculator here because a lot of times it just fits nicely, right? So 3, 4, 6, 6 and 4 is 10, 10, 12, 12 is my sum. And now again, I'm going to divide that by 6 because there are 6 values in the set and I'm going to get 2. So my MAD is 2, all right? And what does this mean? The average distance these numbers are from the mean is 2. So that cluster is nice and tight again. So I would ask you to pause the video and go ahead and do number 3 on your own if you're at home. That will help you, okay? If you're working with me, that's fine. I am going to go ahead and start. 10 and 7 is 17, 18, 19, okay? 19 and 10 is 29, plus 2 is 31, and that is 35. So try and do this mentally. And I'm going to take that and I'm going to divide it by 5, and I'm going to get 7. So 7 is our mean. Let's go ahead and subtract these and see what we end up getting. 10 minus 7 is 3. Minus 7 is 0. 7 minus 2 is 5. Minus 7 is 5. And 5 minus 4 is 1. Let's add them up. 10, 13, 14. 14 divided by 1, 2, 3, 4, 5. Okay. Now, I know that doesn't go in evenly, so I'm going to grab my calculator. All right, and we're going to go ahead and punch that in. 14 divided by 5 is 2.8. No reason to round that, right? So it's 2 and 8/10. And we go from there. I think I've made a mistake here. All right, and I see my mistake because I was looking at my answer key. So let me go back and look what I did. I used that 5 there instead of the 7. So 7 minus 4 is 3. Okay, so let's go back and do this. 3, 10 and 6 is 16. 16 divided by 1, 2, 3, 4, 5. Now let's try that again. So that's just a mistake that I made, and it happens. No biggie, right? 16 divided by 5 is 3 and 2/10. That's what the book says. So there it is. So that is our mean, 3 and 2/10. Okay? So the mean absolute deviation is 3 and 2/10. And what does that represent? That represents the average distance these numbers are from that. Okay? All right, let's take a look at number 4. Coach Jackson found the mean absolute deviation for a number of minutes it took for his PE class to run a mile. Right? The mean absolute deviation was very large value. Jaden assumes that this means his class took a long time to run the mile. Do you agree with that or disagree? Well, you know, this isn't the average distance it is. When the numbers are big like that, that just means you have a bigger spread of data. So the data is more spread out. All right. So the answer essentially is no, I don't agree with that. The data is spread out. All right. Meaning you could have had somebody run the mile in 4 minutes and another person run the mile in 8 minutes. Okay. So that doesn't mean that his class took a long time to run it. It just means that you had one fast person, maybe a couple slow, or a couple fast and a couple slow, and how you look at it. So this is a different piece of evidence to support, all right, your data when you look at it. All right. And that's what you have to understand. Okay. All right. So if we flip it over, here's your homework, and take your time and do a good job with this. All right. We have one more lesson, then we have a quiz on Thursday. All right, guys. Have a good day.